In this session, we are going to see the logic gates. So, logic gates are the basic building blocks of any digital circuits. And the logic gates perform logical operations on one or more inputs and produces a single output. So, there are seven types of logic gates: NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR, and XNOR. In these seven types of gates, NOT gate, AND gate, and OR gate are known as basic logic gates. NAND gate and NOR gates are known as universal logic gates. The first one is NOT gate. NOT gate performs the inversion operation. It has a single input and single output. If A is the input and Y is the output, output will be the complement of input. That means Y is equal to A bar. Whatever we are giving at the input, that will be inverted at the output. So this is the truth table of NOT gate. Only one input A. It can have two values 0 and 1. If the input is 0, complement of 0, 1 will get at the output. If the input is 1, output will be complement of 1, 0. So for 0, output 1. For 1, output is 0. So this is the operation of NOT gate, and the Boolean expression is Y is equal to A bar. Next is AND gate, and this is the symbol of two input AND gate. The two inputs we are taking it as A and B, and Y is the output. Now the Boolean expression representing the operation of AND gate is Y is equal to A dot B. So the AND gate performs logical multiplication. Now we can say the output of AND gate is high only when all the inputs are high. Now, if we say the truth table of AND gate, two inputs we are taking A and B. So, four combinations we can write 0, 0, 0, 1, 1, 0, 1, 1. Now, for the inputs 0, 0, 0 dot 0, output is 0. Next, for the input 0, 1, 0 dot 1, output is 0. Now, next 1, 0, 1 into 0, 0. Next input combination 1, 1. So, 1 into 1, 1. So this is the truth table of AND gate for 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. From this truth table also we can understand output of AND gate is high only when all the inputs are high. So next is OR gate, and this is the symbol of two input OR gate. The two inputs we are taking it as A and B, and the output is Y. Now the expression representing the operation of OR gate is Y is equal to A plus B, and this plus indicates the logical addition. Now coming to the truth table of OR gate, two inputs we are taking, so four combinations we can get. So for 0, 0, 0 plus 0, output is 0. For 0 plus 1, output is 1. Then for 1 and 0, 1 plus 0, 1. For 1 and 1, 1 plus 1, it is logical addition. 1 indicates high. So high plus high, it will be always a high. So the output is 1. So this is the truth table of OR gate. From the truth table, we can understand the output of OR gate is high if any one of the inputs are high. So this is the operation of OR gate. Next we have NAND and NOR gates. NAND and NOR gates are known as universal gates because we can implement any logical functions or any other logic gates using only NAND gates and using only NOR gates. So that is why NAND and NOR gates are known as universal gates. So coming to NAND gate, this is the symbol of NAND gate, and NAND gate is actually the combination of AND gate and NOT gate. That means output of AND gate is complemented using a NOT gate. So this is actually the operation of NAND gate, and this NOT gate is represented by a bubble at the output of AND gate. So this is the symbol of NAND gate, and the operation of NAND gate is what? Inversion of AND gate. AND gate output is A dot B, and that is complemented. So the output expression of NAND gate will be A dot B the whole bar. Now coming to the truth table of NAND gate, two inputs we are considering for 0 and 0. What is the operation? A dot B the whole bar. So 0 into 0, 0, 0 complement 1. Then for 0 and 1, 0 into 1, 0, 0 complement 1. Then for 1 0, 1 into 0, 0, 0 complement 1. For 1 1, 1 into 1, 1, 1 complement 0. So this is the truth table of NAND gate. From the truth table of NAND gate, we can conclude that the output of NAND gate is high if any one of the input is 0. If any one of the inputs are 0, the output of NAND gate will be high, and the output of NAND gate is 0 if all the inputs are high. So the next is NOR gate, and this is the symbol of NOR gate. So NOR gate is actually the combination of OR gate and NOT gate. The output of OR gate is connected to one NOT gate. So the output of OR gate is what? A plus B, and that is complemented using a NOT gate. So the output will be A plus B the whole bar. And this NOT gate is represented by a bubble at the output of OR gate. So this is the symbol of NOR gate. And what is the Boolean expression representing the operation of NOR gate? OR gate is A plus B. So y is equal to A plus B the whole bar. Now coming to the truth table of NOR gate, A, B, 2 bits are there. So writing all the 4 combinations. So for 0, 0, A plus B the whole bar, 0 plus 0, 0, 0 complement 1. Next we have 0, 1, 0 plus 1, 1, 1 complement 0. Then for 1, 0, 1 plus 0, 1, 1 complement 0. For next for 1, 1, 1 plus 1, 1, 1 complement 0. So this is the truth table of NOR gate. From the truth table, we can understand the output of NOR gate is high only when all the inputs are zeros. Or we can say the output of NOR gate is low if any one of the input is active high or 1. Now the next gate is XOR gate. It is also known as exclusive OR gate, represented by EXOR or XOR. Now this is the symbol of XOR gate, and XOR gate, two input XOR gates we are considering. Inputs are A and B and the output is Y. So the Boolean expression for the XOR gate is given as Y is equal to A XOR B. So this is the symbol for the XOR operation. Y is equal to A XOR B, and A XOR B is calculated using the equation A bar B plus AB bar. So A XOR B is equal to A bar B plus AB bar. Now coming to the truth table, again two inputs we are considering. So for 0, 0, A equal to 0, B equal to 0. Substitute in this equation. A equal to 0, B equal to 0 means A bar is 1, B equal to 0. So this will become 0 plus A equal to 0, B equal to 0, 0 complement 1. So we'll get it the output as 0. Same way, if you substitute all these values in A and B, we'll get the truth table as for 0, 0, 0, for 0, 1, 1, 1, 0, 1, 1, 1, 0. So this is the truth table of XOR gate. Now we have to understand few things about the XOR gate. So XOR gate operation can be found out using A bar B plus AB bar, or we can say the output is 0 if the inputs are same. That means for 0, 0 output is 0, for 1, 1 also output is 0. That means if the inputs are same, output is going to be 0. If the inputs are different, for 0, 1 and 1, 0, inputs are different, output is going to be high. Or we can say it is binary addition neglecting the carry. Okay, binary addition. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, binary addition. 1 plus 1 is what? 0, carry 1. So we are neglecting the carry, so the answer is 0. Or we can say the output of XOR gate is high for odd ones at the input. So next is XNOR gate, and this is the symbol of XNOR gate. From the symbol we can understand this is same as XOR gate and the output is inverted. So this bubble indicates the inversion operation. So two inputs we are considering A and B and the output is Y. So Y is equal to A XNOR B. This is the Boolean expression for the XNOR gate. Y is equal to A XNOR B. This is the symbol of XNOR operation, and that is equal to, as I told you, this is the what? Inversion of XOR operation. So A XOR B the whole bar. And what is A XOR B? That is A bar B plus A B bar. If you are complementing that, we'll get it as A B plus A bar B bar. So this is how we need to calculate the XNOR operation of A and B. That means A XNOR B is equal to AB plus A bar B bar. Now coming to the truth table of XNOR gate, for 0, 0 output is 1, for 0, 1 output is 0, for 1, 0 output 0, for 1, 1 output is 1. Just we need to complement the XOR operation. In XOR operation for 0, 0 output was 0. So here it is complement 1. Or we have to substitute these values in this equation AB plus A bar B bar. We can get all these values. So from this truth table we can understand output of XNOR gate is high only when even number of ones are at the inputs, or we can say the output is high if the inputs are same. If the inputs are same, output is going to be high. If the inputs are different, output is going to be 0.